Welcome to Dr. Scott's Maths Made Simple. Tonight we're talking about differentiation and integration. I'm going to do it very basically, very quickly, just so you got an idea of what they are. Differentiation is like this. Y equals x to the n, x to the power n. So the differential, or as we sometimes call it, dy dx, equals the exponential n times x, and you take 1 off the n minus 1. That's the differentiation of that equation. Sometimes it's easier with real numbers. Let me show you again. Y equals x cubed. So the differential, dy dx, equals 3, bring the 3 down, 3x to the 3 minus 1, which is 2. So it equals 3x squared. So it's the exponential comes down the front, and then 1 is taken off the exponential. It's as simple as that. Let me show you another one. Y equals 4x squared plus 2x minus 7. The differential of this equation, dy dx, equals 2 times whatever's in front of the x. So in this case it's 8. That equals 8x to the 1, because you take 1 off the exponential, plus just this number, because there's nothing here, plus 2, and the differential of a constant, or just a number, is 0. So it doesn't count. So you can see the differential is 8x plus 2 of this equation. 8x, 1 comes off that multiplies by that. This is all that's important. I hope I'm not confusing you. I'll just do one more and I'll stop differentiation. Y equals 5x cubed plus 4x squared plus 7x plus 6. Well, the differential of that, if you differentiate this equation, dy dx equals 15x squared plus 4 2s are 8, 8x to the 1, 2 minus 1 is 1, 3 minus 1 is 2, plus 7, and that doesn't count, it's out. You can say plus 0 if you like. So the differential of 5x cubed plus 4x squared plus 7x plus 6, the differential equals 15x squared plus 8x plus 7. That's the answer. Okay, now that I've totally confused you, maybe not. Integration. These are two big things in maths, but this is the basics of what they actually are. The integration, it's done like a big S. It's actually to do with the sum of, which becomes evident later when you do higher level maths. The sum of x to the n. So the integral of x to the n equals 1 on n plus 1 by x to the n plus 1. It's the opposite to differentiation. You're going the other way. So you're adding 1 to the exponential up there. And because there was a 1 here, 1x to the n is the same as x to the n. We've got to end up with, if we differentiate it, getting back to this. So the differential of, say, x to the 5th power equals 1 over 5 plus 1 times x to the 5 plus 1, which equals 1 over 6 by x to the 6th. That's the differential. If we said y equals 1/6 by x to the 6th, and I said differentiate it, you'd know dy dx equals 6 times 1/6, which is 1, times x, and x, 6 minus 1 is 5, which equals x to the 5th. So you can see you've circled all the way back to there. So the integral of x to the 5th is 1 on 5 plus 1 by x to the power of 5 plus 1, which is this thing. And if you then differentiate that, you go back the other way, dy dx, sorry, there should be the d there, dy dx equals this times this, and then 1 off that. So 6 times 1 on 6 is 1, 6 minus 1 is 5, you get back to x to the 5th, which is what you started with. So differentiation and integration are just going one way or another way. So they're opposites to each other, and it's all to do with working out curves on graphs. If you have a curve on a graph, you can work out the area under that graph like that, or you can even rotate the curve around like that, and you end up with a solid shape like that, and you can work out the volume. It's quite an interesting area of maths, but the basis of it is differentiation, which I first showed you, and integration, which is going the opposite way. Okay, thank you for listening. I hope you're still smiling at people like I told you to do in one of my first episodes. Makes a big difference to some people if you just give them a smile one day. And I hope you all learnt something tonight, and if you wish to like and subscribe, you're very welcome. I hope it helps you with your maths. Thank you.